Okay, I'm going to go over a couple of your homework problems with you. This problem says, in chickens, rose comb is dominant to single comb. So this is just a normal dominant recessive trait. Big R is rose comb, little r is single comb. That's the thing on top of their head. It says, what type of offspring would be expected from a white rooster? So that comes from your previous problems. Remember, WW is white, BB is black, and then BW is blue. So a white rooster who is heterozygous rose-combed, who is crossed with a single comb Andalusian blue. So I need to first get the genotypes of the parents. So the parents are heterozygous rose-combed. So that's big R, little r, white. So that's WW. And then the second parent is single comb. So that's recessive, little r, blue, BW. Then I'm just going to FOIL these just like I normally would. So I'm going to do first R, first W, outside R, outside W, inside R, inside W, last R, last W. And then I'm going to FOIL this one. First R, first B, outside R, this outside W, inside R, inside B, inside R, last R, last W. Okay, so now I have my gametes across the top and down the side, and I'm just going to combine them. So this one is big R, little r, BW. This one, big R, little r, WW. This one is big R, little r, BW. I'm putting them in alphabetical order. And last one is big R, little r, WW. Okay, this next column, look, I have the exact same thing up here, exact same things down here. So it's going to be the exact same as this first column. Okay, this one has a little rw. So when I combine these, I'm going to get little r, BW, little r, WW, little r, BW, little r, WW. And then again, this one is the exact same up here, little rw. So, and the exact same across the side, so I'm just going to get the same thing in that column. Now I need to go gather all of my genotypes. So here's one genotype, big R, BW. If I look, these are all my big R, little r's, right? So if I look here, I see 1, 2, 3, 4 of those. So 4 big R, BWs. Okay, then I have big R, WW, and I've got 1, 2, 3, 4 of those. Now my little r's. So little r, BW, got 4 of those. Little r, WW, got 4 of those. What does this one look like? Well, big R, little r is rose comb. BW is blue. So I've got 4 rose blue. You could write rose comb. I just saved space there. This one's rose comb, but what color is that? White. This one's single comb, blue. Single comb, white. And that problem's finished. Okay, this next problem I'm going to go over, only the pre-AP classes had to do, but if you're in regular biology, you feel free to do it for a challenge, but pre-AP classes, this was required. So it says brown eyes are dominant over blue eyes. So I've just got a regular brown eye trait, brown eye dominant, blue eyes recessive. It says it's not sex-linked. Okay, color blindness we know is sex-linked. So to be colorblind, if you're a girl, you have to have 2 of them, right? You have to have XC, XC. If you're a boy, you just have to have 1 of them, XCY. Okay, so it says to cross a brown-eyed, colorblind male. So we know he's going to be XCY because he's colorblind. And we know he's going to have at least 1 big B because he's brown-eyed. But it gives us a hint here. It says his mother had blue eyes. So that means he has to have a little b too. So he's big B, little b. And then he's colorblind, so he's XCY. Okay, And then my female is normal, so she's normal. So she has just an X with no C on it, right? Blue-eyed, so she's little b. She has at least one X with no C on it, but it tells us here her father was colorblind. Well, her father had XCY, and his only X he could give is this XC. So she has to have that XC. So she's normal, but she's a carrier. Okay? All right. Now I need a FOIL. So let me FOIL the male first. So I do first B, and then my first sex chromosome. So BXC. Outside B, outside sex chromosome, BY. Inside B, inside sex chromosome, little b, XC. And then last B, last sex chromosome is little by. FOIL this one. So it's going to, they're all going to be little b's, right? Okay, but it's going to be first B, first X, outside B, outside X, inside B, inside X, last B, last X. Now I'm going to combine all these. So this will be big B, little b, X, XC, big B, little b, XC, XC, big B, little b, X, XC, big B, little b, XC, XC. Those are all females, right? Now let's do some males here. Big B, little b, XY. Oh, I forgot I did all of these at once. You get the gist. So we're going to do our B's together, keep your sex chromosomes together, check yourself, is this what you got? So all of these right here have a big B and a little b. All of these right here have a little b, little b. These two columns are females. These two columns are males. Okay, so we're going to have lots of different genotypes here. So I'm just going to start going here. My first genotype I see is big B, little b, X, XC. And I see 2 of those. And then I see big B, little b, XC, XC, and I see 2 of those. Then I see big B, little b, XY, 2 of those. And I see big B, little b, XCY, and I see 2 of those. Now we have our little b's. I see little b, X, XC, 2 of those. Little b, XC, XC, 2 of those. Little b, XY, 2 of those. Little b, XCY. 2 of those. So our genotypic ratio is 2 to 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 2. Okay. Phenotypic ratio. So now I have to not only tell if it's brown eyes or blue eyes and if they're colorblind or not, but I also have to tell you if they're a male or a female. So I'm going to have 2 females that are brown-eyed, normal eyesight. That's what this is. Even though they're a carrier, they're normal. That's their phenotype. I'm going to have 2 females that are brown-eyed and colorblind. What are these? These are 2 brown-eyed normal males. So 2 males that are brown-eyed and normal. And then I'm going to have 2 males that are brown-eyed and colorblind. Okay, all of these down here are blue-eyed, right? So I have 2 females that are blue-eyed but normal. They're carriers but normal. 2 females that are blue-eyed, colorblind. 2 males that are blue-eyed, normal. And 2 males that are blue-eyed, colorblind. Okay, it says, what's the probability of getting offspring that are blue-eyed carrier females? So right here, blue-eyed, where are we? Blue-eyed. It says carrier, so not colorblind. These two females that are normal, are they carriers? Yes. So it's 2 out of 16. What's the probability of getting of offspring that are blue-eyed? Well, look, all of these are blue. So 2, 4, 6, 8. 8 out of 16, which is 1/2. You could put 8 out of 16. What's the probability of getting offspring that are blue-eyed, colorblind males? So here's my males that are blue-eyed, colorblind. So there's 2 of them. So 2 out of 16. Brown-eyed carrier females. Here's my brown-eyed females, Are these normal ones carriers? Yep. So it's 2 out of 16. Or what? You could put 1/8 for those, by the way. What's the probability of getting offspring that are blue-eyed normal males? Right here, 2 out of 16. What's the probability of getting offspring that are colorblind? I've got 2, 4, 6, 8 out of 16, or 1/2. Okay, that's it. Watch it again if you're lost.